Okay, here's our example that we're going to do. I think I do only have one example. But, so we need to find the projection of u, the vector, which is 3, 2, onto vector v, which is 5, negative 5. Then we need to write u as the sum of two vectors, and one of them is the projection of u onto v. So we will do that last. First up, we need to go ahead and find the projection of u onto v. By definition, the projection of u onto v, if you can think it's like sitting on top of it, so the v is the lower one, if that helps you think about it, that's dot product of u and v over the magnitude of vector v squared all times, I guess I shouldn't do the dot, I'll use the parentheses, vector v. So u and v, so 3, 2, dot 5, negative 5, over the magnitude of v squared. So that means when you're doing the Pythagorean theorem, you're not taking the square root at the end. So that's going to help you out. So that would be the magnitude of 5, negative 5, oops, put the vector sign on there, squared, all times our vector 5, negative 5. I'm going to go ahead and change pen colors because this isn't very easy on the eyes. All right, so let's go ahead and take it step by step. Dot product, we've got 3 times 5, which is 15, plus 2 times negative 5, which is minus 10. So that gives us a 5 on the top. And then on the bottom, we've got 5 squared plus negative 5 squared, which is 25 and 25, which is 50. Then we need to multiply that by 5, negative 5. How are we going to do this? Well, we are literally going to take those values and multiply them across. So that gives us 25 over 50, comma, negative 25 over 50 as the vector of v onto u. However, that can be reduced down to 1/2, negative 1/2, and that is the projection of v onto u. So now we can see that projection. We need to rewrite it, write vector u as the sum of two orthogonal vectors. So the two orthogonal vectors, we know just from definition in the prior slide. Hold on, let me erase this. All right, we know that we need to find W2. U, the vector, is equivalent to W1 plus W2. So W2 is equivalent to vector U minus W1. W1 is equivalent to the projection of V onto U. So we can actually write this as W2 equals U minus the projection of U onto V. Not V onto U, U onto V, sorry. So how we write that? That's 3, 2, the vector, minus 1/2, negative 1/2, the vector. Don't overthink it. This is one of your properties where you're literally subtracting. 3 minus 1/2 is 2.5. Writing that in the fraction form, that's 5 over 2. Not 5. 5 over 2. 2 minus a negative 1/2 is 2 plus 1/2, which is 5 over 2. And we can go ahead and I'm going to move this equal sign over. And we're going to write this as W2 equals 5 over 2, 5 over 2. Now, the last piece, it says we need to write it as the sum as the vectors. So we've got W2, and we need to write projection of U onto V, which is W1 and W2. So we're going to write that as U equals 1/2, negative 1/2, because that's our W1, plus 5 halves over 5 halves, and that is it. So that is the sum of the two orthogonal vectors. This is W1, which is identical to the projection of U onto V, and then this is W2, which we found, and that is it. So make sure you go back, understand the pieces. You will have this on homework.